There you go. Yep.
Okay,
It's there.
good to go.
All right. So our next pump will be progressive or progressing cavity. We actually have hired the regional rep about 2 years ago from Moino, and I always called it a progressive cavity. And he's adamant it's a progressing cavity, so we're getting the battles about that. All right. So the basic setup on a progressing cavity pump, the principles is that the pump operates by having a rotor and a stator. And basically the setup has that we're using a single helix metallic rotor, and that's going into a double internal helix stator. So what it does is basically it allows for a cavity to be created, and as we rotate that, we collapse those cavities and progressively push the fluid from the suction to the discharge of the pump. As it rotates, it keeps intimate contact or sealing points, almost similar to the gear pump, where we're sealing off that cavity as it rotates. So it's either in a static position or a dynamic position as it rotates, depending on where the fluid is in that cavity. So I kind of got a picture, little automation that kind of shows you exactly, and you can follow the little bubble that comes through. That comes into the pump, gets into that single helix, double helix stator rotor combination, and as the rotor turns, we open up that cavity, collapse it on the other rotation, all the way down, producing your flow. If we look at the end of the pump or the side view, the outer area would be your stator, and the inner it would be your rotor. As we turn at 0 degrees turn, our rotor would be at the top. At 90 degrees or at 270 degrees, depending on where we are, we would be in the middle, and at 180 we would be at the end. So about a 360 degree turn, we would do that recirc, or that full position twice. So just like just like the centrifugal pump, these pumps also have stages as well, and the same reason, it's to produce more pressure. The only thing that's different is the stages are basically, I guess, humps or cavities. So in this setup, you can see about two humps or two cavities is a stage. So if I increase it to a 2-stage or a 3-stage or a 4-stage, I'm adding a longer stator, more cavities, and a longer rotor. But I'm able to then increase my pressure, and you can see down at the bottom. So I'm going from a pump that's able to do 250 psi in a 1-stage up to a 500-600 psi pump with adding on multiple stages. One thing on the progressive cavity, and again, similar, since they're the same, we're still in the rotary positive displacement pump. We have slip. So as we increase pressure, as we increase pressure, increase wear, we introduce the ability to slip. So when we look at sizing and selecting the pump, that's a big factor that we need to look at, especially with this pump, is we want to decrease the potential slip or buffer ourselves if there's a high likelihood that we know that slip would occur. So one of the big things in a lot of changes,
I think it's on.
you know, over the years with the pump, with this pump is the geometry of the rotor and stator. Okay, by changing the rotor diameter or the rotor movement or the pitch of the stator, we can produce more flow, less flow, higher pressure, more efficiencies, use a lower horsepower motor, so on and so forth. And in this case, if you see in the top picture, we have a compacted rotor, okay? And then on the bottom, we just elongated the shaft longer. We actually are able to reduce some of the horse power or the thrust loads that the pump sees overall. So that's what I'm showing you here. So I want to get into some of those geometries, and let's pass some of these out. The first one is the S geometry, rotor and stator combination. You can see that there's multiple cavities. Basically what this allows us to do is to be at a medium range, about 100% flow and 180 PSI. We got the L geometry. You can see much different, more elongated, but we'll have a less of a pressure with this one. And then this one, it's I think the Germans were bored. This is a German manufacturer. They're probably bored at this point. And that's the geometry. We're able to do a significantly higher rate of pressure with this one. And then we have our P geometry as well. Again, higher flow rate with the P geometry and about half of your pressure. I want to say probably in easily the last 25 years, you see a move. Some manufacturers haven't adapted to changing the geometries of the rotor stators, while others have gone to the extreme. In our case, we've rep several manufacturers. One is Netch, and they offer all a full range of different geometries of the rotor stator combination. Others might only have one or two options. So let's look at them a little bit further. So the S geometry, we got smooth conveyance, compact dimensions despite high number of stages, large cross section of rotor inlet, low flow velocities, low NPSH requirement, conveyance compacted products as possible, conveyance for large solids. One of the things with these pumps is we're able to pump solids. And when I say solids, I'm talking about apples, whole fish. We can pump whatever, and basically if we want, there's a lot of applications where people don't want the solids destroyed. So we need to size the cavity to be able to handle that solid and we would freely transfer it and convey it through the pump. Fish is a big one. Fish naturally, instinctively will move upstream. So as it's going to the pump, it will move to the next cavity. It will actually help and assist. So that is a
They'll still be alive at the end, right?
What?
They'll still be alive at the end.
They'll still be alive. Oh yeah, yeah.
Are those what those fish elevators are that they put in?
Oh, I'm not sure, no. But we got like one of our big customers is Ocean Spray.
When the door closes,
We're pumping all those cranberries, and the last thing they want is the cranberries
it's
to
hard to
be
train them.
broken up and destroyed.
You need a big dorsal fin.
These pumps are shear sensitive, So your hand creams, I mean, big into that pharmaceutical, hand creams, lotions, gels, shaving cream. Procter and Gamble is a big client, you know, those type of places. Now, the next one is, you know, is the L dimension, good volumetric efficiency, long service life, due to a long sealing line between rotor and stator. It's compact in compact dimensions together with high flow rates, reduces rubbing and velocity. That's the one thing with, because your rotor and stator is in intimate contact, dry running these pumps is very bad. So you don't want to dry run these pumps at all. Manufacturers put in a temperature sensor, and the problem with the temperature sensor, by the time that temperature sensor goes off, the damage is done, more often than not. You see the D, extremely compact dimension despite high pressures and flow capabilities, almost pulsation free, high dose accuracy, so great for metering.
Dave, is that because the stages are closer
Yeah,
together?
the stages are closer together, so you have a smaller rate of,
Right, dosage.
you know, if I was in a bigger like this, you're getting more of a slug, right? So you're gonna have a volumetric slug as it rotates, versus this, you'll have more consistent flow rate. This is what the D dimension is typically on the smaller size pumps, and again, great for metering. These pumps actually really, and they're not used for metering as much as they should be in the market, because they handle solids. And you know, when you get into really tough applications that you want a pump that can get beat the hell out of and last, this is the pump. People really look at it like pumping sludge and, you know, this and that, but on the metering end, these pumps are actually really fantastic metering type pumps that are seldomly used in metering applications.
Is it because of price or?
No, I don't think it's because of price. I think you know, you've got other pumps that are deemed metering pumps. So I think other technologies are typically looked at first because of just the association with the word metering.
You might have said already, but what's the biggest application you see these in?
The biggest by far is in the municipal, dealing with sludge,
Okay.
sewage, waste,
Oh, okay.
polymers. Municipal, every single municipal plant has these pumps, and probably many of them, depending on the size.
Food processing uses a lot of this too.
So then the next thing, if you start looking at waste, so what's the next? Your largest users of water are pulp and paper, food, and municipal, right? Those are your largest use. So when you get into food plants, the waste stream of a food plant mimics that of a municipal plant. You have, and then the same challenges persist where you need to neutralize your waste, and then you need to separate your solids, you know, all that, de-water, all that aspect in a food plant, in the small food plants, but a decent sized food plant mimics the same. And that's likewise when you go into a paper mill. They have that same challenge and same scale. So yeah, all those three industries, especially on the waste side, they're in there. On the flip side, when we talk about production, definitely it's food and pharmaceutical. Dog foods, hand creams and lotions, acne creams, all day long, gels, anything shear sensitive, biopharmaceutical. We're not sharing anything. All over the place in those applications. We went through the P dimension. All right, we'll get into, so attached to the rotor and stator is your drive shaft, or your stub shaft, which is connected to a universal joint, just like your car. You have a universal joints in your car, so it's basically the same thing. When the pump rotates, there's actually a level of eccentric movement. You can see that it's not, straight across movement. There is a eccentric movement to the pumps. Same thing here. Okay. So there's two types that are most common. It's called the pin joint and a gear joint. There's a picture of them both, and I have these right here. So the pin type, which he has, is basically. So basically, it's encapsulated, and it depends on manufacturers. So you got a pin and a ball. It's basically how this is set up. We get this sealed encapsulation, so that way any of the process, mind you, this is all into the process fluid. So you want this nice and closed. You want this greased and lubed. Nothing to get in there. Now on this manufacturer, they have it fully encased. Others just have what's called a universal joint sleeve. This rubber boot that actually would slide over this assembly and gets tied strapped. See this like little ring? This little tie. Yeah. So depending on the manufacturer, and there's some a degree of difference in costs depending on what the solution is there. And I'm not sure that customers that's always communicated effectively to the customers on what the benefits of the different types of universal joints there are. So this is a pin joint, if you want to pass that around. In municipal application, this is the gear joint. I mean, very robust, much more expensive than your pin joint. And you can see it operates off of a gear, fully enclosed. Again, highly robust. This. I'll go through the slide. You guys can take a look at it. Yeah. So on the pin type, a simple, robust design, maintenance-free, high-quality SM seal. It's an oil lubricated. Most common, most economical joint on the market. External sleeve is in stainless steel to protect against ingress of solids. Optional with hardening or replaceable bushings. You can see on the gear pump, long service life due to transmission of torque and actual loads are on separate paths. Preferred for continuous operation under high loads. Double seal design, therefore optimal chemical resistance to pump product and optimal joint lubrication. Installed patented oil groove in the cup, ball cup, guarantees lubrication under heavy load. Let me get into the main components of the pump.
Okay.
The majority of progressive cavity pumps do use a double mechanical seals. Typically they're a Bergman type 21, and they have other slurry seals and a lot of different combinations. But just to break down what our components, so on your pumping end, you use your rotor and stator, and that's mounted off with tie rods to your main adapter here. This is your inlet. This would be your discharge of the pump. Your gear joint or ball joint would be riding right here. You would have, I call it a stub shaft or a connecting rod that connects up to your drive shaft over here. Okay? I got this cutaway on the pump so you can see. So, like I said, here's your rotor and stator. We got your U-joint, your connecting rod, your mechanical seal, and then back here, you typically would have a gearbox, and then a motor attached to that. Operational speed is you typically never over 500 RPMs. Very rare occasion would you even be close to that speed. And due to the degree of abrasives or solids, you would be from maybe a range of 120 RPMs to about 300 RPMs. Typically, I'm more conservative. The worst thing for a PD pump is the pump salesman. Because the problem is that when you look at the curve tells you can operate at a certain flow rate. On a PD, you want to oversize, you want to be bigger and slower is better. But when you're out there, the price point, I think pump, like pump guys get nervous about the price point, because if we go a little bit bigger and a little bit smaller, a little bit faster, price point's more attractive. So just be mindful that, hey, let's sell on that we're providing you the best solution for your long-term benefit, rather than selling you something that is less expensive, and not be worried to have that conversation with the customer. Just gonna pass this around and play with it. So here's some of the capabilities and features of this pump. We can handle up to about 1,500 PSI. He was talking about application of 2,000 PSI, so pretty close there. Flow rates up to about 2,000 gallons per minute. Viscosity is about 1 million centipoise. That's probably like tar.
I was gonna say, what's a million?
It's probably tar. That would be a good moves abrasive fluids, non-pulsating flow, very low MPSH requirements for the pump. Just as long as we can get the fluid into the pump, that's really the MPH is that low. Flow proportional to speed, so we do have a true fixed displacement. So depending on where we're operating on the speed curve, we can reduce speed and reduce flow and maintain our pressure. They're relatively quiet in operation. We have no valves to gum up. Discharge pressure is independent of speed. We can reverse it, low shear pumping, pass solids to almost 2 inches, and even bigger. Will not vapor lock, so if we have any off-gassing, entrained, air pocket, anything like that, it's not going to be an issue. Suction lift up to 28 feet. We can do corrosive chemicals. Temperature's about 425. Inherently, it's self-priming. Handles the high solid concentration, and then flow is slightly affected by pressure. There's several different mounting configurations that we have for the pump. We can do an L-shaped base plate where your motor is off-center to the left or to the right. We also could do the pump with motor and gearbox on top of the motor, or we could do a belt-driven where the pump, motor, and gearbox of the motor is above the pump, driven off of a belt. And then back to the applications. So creams and lotions, cosmetics, dog food. We do a lot with dog food. Renderings, rendering plants. Not that anybody really wants to be there. Not the funnest places around, but definitely great applications for these pumps. Cranberries, concentrated fruit juice. People think juice. If you go to the plants, that concentrated fruit juice is pretty thick stuff. It's pretty nasty stuff actually, but we do a lot with those. Fruit pulps, whole fish, sludge, mixed liquors. Alum is a big application. Polymers, adhesive and glue, gels, latex, lime slurries, cement or stucco material, greases, And I throw in a couple that we don't really do much in the oil and gas, but downstream oil and gas, that's when they're refining the oil and gas, or upstream oil, which they're doing exploring wells and whatnot. Those are the typical applications. You guys got any questions on that?
If your application changed, could you change your rotor and your stator and keep the same gearbox?
Absolutely, we do that all the time. We work with a paper company up in Maine. And the challenge is with being a specialty paper manufacturer is cost. So everything's driven off their cost. So if they can get lower cost dyes and inks, they'll make that change immediately so they can stay competitive. Which a lot of times means material compatibility of the stators need to be altered. But yeah, we regularly can go in. Some applications, if the gearbox is sized accordingly, and they need to increase flow rate, yeah, we can change that rotor and stator combination and give them more flow rate and whatnot. Yeah. So it's similar to changing the impeller size on a centrifugal. So, all within limit though. There's only so far you can go. But yes, that's definitely, if they want to downsize or increase size, we can do that.
You guys seen any of these pumps out there like that? The Progressive Caddy ones?
No.
Just Ventura Foods had an application years ago. I'd never heard of them. and
They're out there.
For their
They're
wastewater.
definitely there.
Yeah.
Yeah, they're definitely the bigger is definitely that sludge or arena.
Probably you guys if you recognize them because what the heck is that there?
You know what's funny? It's you ever see the drilling trucks? The well drillers. There's a pump. There's this pump mounted on every single one of their trucks. Yeah, it's right on the side. I see it all day long. I'm like, really. And the nice thing, the price point. We're talking. I did 2 pumps this year, $75,000 each. I mean, some of these, depending on in that case, that was a remediation cleanup site. But you're talking some substantial money. It's not a small cell.
And the stators are gonna wear out,
So-
probably, so.
So for us as distributors, one of the best thing is recurring revenue. Okay, the pumps like this, pumps in general. Your recurring revenue is not solely new pumps at a facility, it's your replacement parts. So the nice thing with this pump is your recurring revenue is your rotor and stator. That will wear. The rate of wear depends on how well we selected the pump for the customer, or how well he was he financially reduced the size of the pump because of financial means, but all depends on that. So anytime we're talking about positive displacement, the rule of thumbs, bigger, slower, better. And then if we sacrifice some of that, then we increase the rate of failure.
The joints generally hold up.
Yeah,
Well-
the joints hold up. So your main failure would be your rotor and stator, and then probably followed by your mechanical seal. But yeah, the joints hold up pretty good. If you don't maintain, like in these 2 examples of the joints, highly robust, but like others where you're just using a rubber boot and you're not maintaining it or not checking it and you're allowing product to get in there, then you can have an issue. If that's a breach and you just don't care about it and don't do anything about it, you'll wear out that pin area and you'll get some slip. And once you have that slip in that gear joint or the pin joint, you're gonna have some issues. On the gear joint, I've only seen maybe several real failures as the result of the gear joint. And we're talking probably the worst applications you could be in. So it's pretty solid.
But it's more money too, though, right?
What?
It's more money though, right?
Oh, yeah, it's more money. When you get into the, I mean, at this point, the engineers in the municipal arena know what they want. And if it's a municipal application, 9 times out of 10, it's gonna be a gear joint that they're gonna want.
Kim, you guys deal in municipal at all?
Mm-hmm.
Yeah.
Yep.
Yeah, I mean, that must be a big area for you guys, no?
And we have a CoStarz contract now too, so, yeah.
I think it's, they end up on price you for everything, municipalities, right?
Well, with CoStarz, you can buy up to, I forget what is that, 10 grand?
I think it was 5, yeah. I don't
Up to
remember.
$5,000 or $10,000 without even putting out for bid.
Right.
And that's local municipalities, so.
Yeah. That's what they all have now?
I think it's either 5, I thought it was 10,000, but I have
Might
to
be.
check one to see, but it could be
Right,
5, yeah,
Okay.
so, yeah.
So the next pump we're gonna talk about, I don't love this presentation, but we'll go through it. So it's a hose pump or peristaltic, and there's two differences. A peristaltic or a tubing pump uses a tube. It's typically a dry running, so there's no lubrication in the pump. Then there's a hose pump. Hose pump uses a hose, a legitimate hose, very thick, very big, and that comes into two different categories. There's this pump, which you grease up the hose, or there's a oil lubricated pump, where half the pump actually contains oil and keeps the hose lubricated. So real simple, the peristaltic pump works by having multiple rotors fixed to a drive shaft and a tube wrapped around it. As the rotors include the tubing, it creates a cavity of fluid. And again, we open the cavity on the suction, we're pushing that cavity through the tube all the way out to the discharge. And that's, basically how the peristaltic on a hose pump. People do it in a lot of different ways. So some would replace those rotors with like a single roller that moves on an eccentric movement that actually would occlude the tube. Others use 2 rollers, all different types, but essentially the same action where we're occluding the tubing is taking place. So these pumps are found, so hose pumps are found in, people tend not to get to a hose pump unless they need to. Very expensive upfront price based on their flow rates. But I'm able to do solids. Whatever I can get in this pump is coming out on the other side. We saw hoses, about 20-inch hose on some of these. And again, it's the same thing. If you want a whole apple, I'll be able to pump the whole apple.
Watermelons.
Yeah. So they go from very small laboratory. If you guys are in labs, they're pumping small cells and solvents through these pumps on a smaller level. And then as you progressively go up, you could get, most of the tubing pumps end about 10 gallons per minute. That's where you start seeing that these hose pumps will take off. Here's some of the, this is an OEM type pump. You can see here that there's 2, 4, 6, 8 rollers on there. So the more rollers, the less pulsation that you have out of the pump. So most similar to the progressive cavity and others that we've seen. typically on these types of pumps, you're gonna get about 35,000 centipoise in viscosity. Your limitation is the hose. So, you know, you typically have about 4 or 5 different hose materials, Buna natural rubber, nitro, maybe it's Santoprene or neoprene, Hypalon and Viton. And then anything beyond those tubings are really not often. So you gotta be within, that's your limiting factor is what the material is. They got the food grade material, natural rubber food grade and whatnot for the food and pharmaceutical. Pumps are great for food and pharmaceutical because we don't share the product, similar to the progressive cavity pump. Hoses are replaceable. So you can take the hose out, throw it away if you're pumping cells or, you know, food, and just simply replace with a new tubing. Relatively easy to repair. I remember when we first got a hose line on, I was up at Hinkle Loctite, and I had this John Cronin, I remember his name, John Cronin. He was always a stickler, you know, asked every question in the sun, and, you know, really dragged you through the whole project, you know, asking every question. And you guys all have some of those, but those guys are great. That's where you go with the new product, that'll beat you up a little bit. That way, you know what the other guys will be asking, you know, well in advance. So I told him, yeah, this pump is easy to repair, but take me 5 minutes to replace a hose. He looked at me, he says, you replace a hose right now, I'll buy 2 pumps. I was like, uh-oh, it better be 5 minutes, you know? So yeah, it was 5 minutes, and basically, in this, take off these 4 bolts, rotate the shaft, or if it's in line with the motor, bump it, and the hose comes right off. And then if you put the hose back in, you slide it back in, set these 2 screws, and you're off to go. In the case with others, they have what's called a, yeah, you guys can see that. Try this thing out. You see right here, this is called an easy load. This lever comes right up, the whole cartridge slides up, and it allows you to put the tubing in. So on the maintenance end, very easy maintenance. The other aspects that are advantages with this pump is no valves, no nothing. It's simply just the tube. So just like a gear pump, your flow is based on rotation. And you also have a known fixed displacement. The only variable you have, just like I guess in the gear pump, your variable is that your gears start wearing, and that's linear. Well, you have similar with the tubing. As that tubing is being used, you have thermal expansion, because it's always in contact. So you have a slight variance at some point as the tubing wears. The other issue that you have that's probably a drawback is it's the tubing. So inherently now you have a consumable. Tubing, if I was to size a hose pump, typically your best application without going well oversized is about 90 days use of a hose. And similar to that in the tubing pumps, so you're getting around 90 days, that's considered very good. In a hose pump this size, that tubing's probably a couple $100. Bigger could get up there in thousands of dollars for one replacement hose. So the other thing is that these pumps are used, at least in the laboratory, a lot on dispensing. I've done a lot of dispensing systems. And what happens in the dispensing is you play a game by sacrificing accuracy for time. Okay, I'm able to adjust in the tubing pump, the tubing sizes. I can go to a micro size tubing to a 3/4 inch or 1 inch. And by doing that, I sacrifice my accuracy with the larger tubing, and increase my accuracy on the small. But the one thing you do that gets impacted is the time. So when we look at, you were saying you were doing a dispensing application, right, with a peristaltic. That's the one thing that, when I go to size it, I try to figure out what point do I need to be at? Is it more accuracy but sacrifice the time in his production run, or go find out what the best scenario? Or do I have to go the other way? Small ID, low flow rate, long dispensing time, high vacuum, high suction lift with these pumps. You're almost at vacuum. So vacuum is what, 31 point something feet of lift. In this pump, you're doing about 29, almost 30 foot of suction lift. So these things can pull and self-prime better than others. If I sat here and put my hand on this and rotated this thing, you could see I'll suck in my skin and give myself a hickey. I'll try that later, maybe.
Back on it.
Yeah. And then again, with the larger ID, so we're going to do higher flow rates, faster dispense time. Again, depending on if you have solids, we can handle the solids. We just need to make sure that we size the tubing accordingly for that. Just like the gear pump, pretty much a linear curve, straight across. You can see here on these curves, these are all dictating different tubing sizes. So that's the difference. And similar to the gear pump, you got water-like, center poise. It's all based on speed. In this case, it's a percentage of speed, 25, 50, 75. That's because, in this case, and not all pumps, the max RPMs on this pumps that I see out there, about 600 RPMs. Typically, the majority operate 125 RPMs and below. So you want to operate these smooth, really small, really slow. Because mind you, we're using a hose. We're using a flexible component here. So in this case, this curve, this pump is operating at max RPM 125. So when we look at that percentage, it kind of tells you, that 25% we might be at, 30 RPMs or so, whatever that would be. So you can see the 200 center poise up to 17, and then 1200, your flow rate reduces considerably based on the viscosity. So when handling higher viscosities, that's where I would say the progressive cavity on the higher end will always outperform the hose pump in handling higher viscosity. So you're pretty much, I would say, your limit would be about that 35,000 center poise, where the PC pump's gonna go 1 million. So the following tubing specifications have particular effects on the pumping, and that is the inner diameter, how thick the tubing is, and the formation. The combinations will have different effects and behaviors on the pump. You can see here, this is one of the designs they made more so for the pharmaceutical, where they're using a convex roller on a concave bed. So basically what they're trying to do is, this is your outer flex would be your weak point. So if they're flexing into the middle, they can increase your wear. This is also ideal for like cells or whatnot, because we're not going to be crushing or destroying the cells as we're pumping through. So again, if you get into that lab arena, this is the pump of choice. Cleanability, reuse of tubing is desired. So basically, When you get into pharmaceutical, everything's disposable, and this falls in suit. Limitations is, basically our differential pressures and discharge pressures are lower than a gear pump or a piston. Limitations available due to the tubing material. Tubing will eventually leak. Pulsation is inevitable. Tubing requires recalibrating after changing. Tubing requires a run period when installed about 1 to 2 hours. So you want to have a break-in period of that tubing. We've got here a pulsation dampener. I guess I can show you what that is. Let me that box. So pulsation dampener is a device that will dampen pulsation in a line. This will help with like water hammer applications, or if you have a flow meter or whatnot. Used on peristaltic pumps, as well as double diaphragm pumps and the single diaphragm metering pumps. Basically what you do is whatever your discharge pressure is, you charge the top half of this dampener, about 80% of your overall discharge pressure. And basically what this is just a bladder. So this bladder takes up that dead spot in your volume. So sized correctly, you could get up to about 98% reduction in your pulsation. And that's what this is. Feel free to take that apart.
Did you guys ever see those installed?
Did you ever notice
On
that?
AOD pumps.
Maybe.
Down AOD,
I would say AOD or metering pumps is the biggest.
Now, Vic, if you're in the hospital, you're comfortable sizing your own IV pump?
Turn it up. Depends on what's running in the IV.
Yeah. Faster.
some morphine going through there.
So, there's a lot of different setups on the laboratory scale. We handle Masterflex. What's nice about Masterflex is they have a very broad range. So very small, low flow rates, nanoliters, to all the way up to several hundred gallons per minute. So they get probably one of the broader ranges out on the marketplace. But we also work with other company. This is actually a blue light pump. And you'll see manufacturers cater to an industry, and Blue Light caters to that municipal market industry, so they do a little bit different. So in the case with Masterflex, we got like an easy load levered pump head. It's not enclosed, the tubing fails, the leakage is there. Then you have this pump where it's fully enclosed. These use tubing, a roller tubing. You cut it to fit. You use whatever size tubing. These uses tubing elements. Right? Your connection, in this case it's an MPT connection, is already a part of it. The element itself has a set length of the tubing. What they do in this, and the move in this marketplace is, so we have this enclosed. They have a reed magnetic switch on this housing. So if somebody takes the housing out, the pump knows there's a signal back or stops or whatnot. And they also have a conductivity probes. So if there's chemistry, if that hose is ruptured, one, the fluid's contained, and two, the pump acknowledges that the tubing has leaked. So in a lab environment, that's not as desirable. But if you're pumping sulfuric acid in a pharmaceutical, a municipal facility, that would be something you would be worried about. The lab usually operators there, so it's more of a hands-on process. So well as others, but in this case, so what we're showing here is a lot of these pumps are stackable. So we can stack multiple pump heads and have different rollers. It gets to be interesting because although I can't control speed for each individual pump head, all of it will be rotating at the same speed, I can change the ratio of dispense by my tubing ID. Doesn't always work out, but occasionally you're able to do, if I need to do a batch, and my batch is a 1-to-2 ratio of product, I can go and take 2 pump heads, have a 1/2 inch ID on one and a 1/4 inch ID on the other, and get your 2-to-1 ratio dispense. So they can do a mix. So you get into some interesting things that you can do on that end of those pumps. So there's no contact with the fluid other than the tubing. Again, highly desirable in pharmaceutical, biopharmaceutical, and food. Tubing is the only parts that really wears. I wouldn't agree with that, to be honest with you. That's your main wear item. Mind you, there's bearings, there's pins on these rollers, other things wear. So, I don't wanna mistaken you there, but yeah, your main wear item is your tubing. Service and maintenance costs are minimal. I would say more the easy to repair, which probably drives the cost down more than anything. Easy to clean, sanitize, insensitive to dry running. You could run this all day long with no fluid in it, and then you have that multiple channel or multiple pump head configurations. And here's a couple of the other options where we're getting into a bigger pump head, and even in this case a smaller. So some of the advantages of the pumps, again, we're at that 30 foot of self-prime. Tubing is the only wear part, no check valves, and that's really when you start looking at diaphragm pumps, single and double. You have ball checks that are required to seat, so no following of check valves. No back pressure valves are required. And that's an interesting one. I've gone up against the Mass DEP at this point, because diaphragm pumps require you have a set back pressure. Peristaltic, I'm running on a tube. Any additional back pressure against that tube doesn't do me any good. I get a tube. So if I can lower that, one of the reasons they can rate back pressure is to maintain the fixed volume displacement. You would have some variance based on where your back pressure is on your fixed flow. That's one of the parameters that can change what that fixed flow is, and you calibrate the diaphragm pump. In the case with a peristaltic, I don't want that back pressure, and I always have one roller that's occluding the tube. So I don't have a concern if I'm injecting into a stream. So I get a city line that's going 7 gallons a minute, across, and I'm injecting chemistry into that stream. There's a potential that that stream's creating its own vacuum and actually could siphon chemical in despite the pump. So that's one of the concerns, and that's why you have a back pressure valve or an anti-siphon valve. But in the case with a peristaltic, I'm always occluding the tubing, so I don't have the possibility for siphoning to occur. So no siphoning, suspension and solids with sludge with solid content up to 60% to be pumped. Air and gas is not an issue. We won't get vapor locked. Can provide much more continuous flow than traditional solenoid metering pumps. Some units, or most units at this point, have some level of leak detection. So drive options, typically about an IP66 drive for the majority of them, or if it's a motor, if it's an AC motor, we either do that with 56 frame mounts. Motor could be washed down, explosion proof, etc. We can get drives that run on compressed air, and we can put in standard VFD controllers. You see this controller up here, it gives you some level of functionality. So they're determining fixed displacement per rotation. So if you go in here, you can select what tube size it is, and it will give you your theoretical flow rate, or runtime, or totalization. So one of the things that was always good about Peristaltic, they were on the cutting edge of drive technology in the pump world. And so a lot of the pumps manufacturers, when they look at controls aspect, they're adapting what Peristaltic has been doing for the last 20 years. But the nature of these pumps, they were centered around lab. So that was more of a requirement in that marketplace, and really didn't need to be a part of the industrial or municipal world where it's applicable now. Here's some of the advancements that we've seen over the years. So one of the things, like I was telling you with that multiple channel, we were stuck where even though we had multiple channels, or in that case multiple heads, I was stuck that all of them rotated at the same direction, same rotation. IDEX company actually came out with this new pump that each of these assembly, although it's locked into one pump, operate independent from each other. So I'm able to do a lot of different interesting things. So I can control this head to operate in what direction I want, at whatever speed I want. This one's independent as well as this one. So when we talk about batching and doing different applications, that really opens up the door for what we can do.
How do they get that to do that?
Could be gears in there.
Yeah, there's
planetary gear sets in there or something.
There's absolutely, there's multiple planetary gears in
These
that.
are pretty expensive pumps.
Yeah. There's what is it? The small, not pressure vessels. I forget the name, but there's one applications in the laboratory, a reactor application where you have to do multiple chemistries, and this pump fits in very good in that application where we're doing 3 different chemicals all at the same time to make the reaction and do a cleaning cycle all at once. So it's very interesting and new. So this came out 6 months ago. This is newer than what we're seeing.
If we give you guys a model of, like, I have a customer that uses a Stenner pump, would you be able to cross that over to like an LMI or pulse feeder or something?
Yeah.
You guys.
This is how I work. Two things is we can easily cross-reference pumps. I think it's more important to know what your customer's doing, because then we could probably give them. I prefer, my method is consultation and selling. Okay? So I look at an application and I figure out the multiple ways I can go about handling that application. Because I have about 80 lines. I have some substantial amounts of lines. So I'm positioned to be able to do that. So we sit down with the client, I give multiple options to you, we convert the Stenner, understand what his issues are, and specifically pinpoint his needs. We come back with multiple options and then pull him in the process of making that decision. That's the preferred. Does it always go that way? No, but that's the preferred method. If we can go into that, I think we're doing the best by the customer. Because there's more, you see, there's a lot of overlap in all these equipment, just on nature of their design. And then you have the manufacturer that has made their pump with specific features and benefits for whatever industry or what niche application. So I try to pull that together and present it on that end. So if you had the stunner, I would say, yeah, send over the stunner, I could cross-reference it, but get that application and find out, why isn't he happy with that stunner, and let's go from there.
By the way, that's what I do, so.
Any other questions on this, or?
There actually is that pulsatron, you're talking about the Stenner, and this is the pulsatron, which is a metering pump as well. I'm sure you saw these
Oh, yeah.
in some of your,
Yeah.
just like the yellow LMI.
Yeah, that's, yeah, the
is
LMI.
out there
You've
as
got all
well.
your customers using those.
Yeah.
They're out everywhere, they all
Yeah,
have
they're,
feeders.
yeah.
And
they're
if
out
you,
there.
I would venture to say you walk into most customers and see something, they're doing steam or doing any type of water injection or chlorine, anything, they're using these pumps, so.
Absolutely.
Yeah.
The interesting thing with, so this is your traditional metering pump. So when somebody says metering pump, that's what they're
That's what they
thinking
mean,
about.
yeah.
The interesting thing about that market is you can tell the manufacturer by the color. Right? One of the
Stenner's
few.
green.
LMI's
Yeah,
yellow.
okay, LMI's yellow, this is a Pulsatron is blue, you know, Milwaukee's red, and Prominence orange, or whatever, so you can easily tell what it is. Yeah, Pulsafeeder. Yeah, they were both owned by IDEX. Pulsafeeder, I could go into that. I'm done with I get plenty of presentations and stuff to talk about. But, so on this pump, this is a solenoid-driven pump. So we activate a solenoid to produce reciprocation of that diaphragm. And you can see that's actually a cutaway. So that diaphragm flexes back and forth to produce flow. See the white diaphragm? So when we engage and charge the solenoid, it will either pull the diaphragm forward or back and produces flow. So in those threaded MPT connection ports are two check valves. They're ball checks. So on your upstroke, your suction ball lifts off the seat, allowing fluid to come up into the pump, and then on your discharge stroke, the ball seats on the bottom and elevates off the top of the check valve to allow flow through it. There's been a lot of changes with these pumps too, from solenoid to stepper motor technology. The three driving methods of these pumps are solenoid, motor driven. Then you've got what's called hydraulically actuated. And what that is actually we have a piston, and that piston drives fluid on the back side of that diaphragm. And it's actually hydraulic fluid that flexes the diaphragm. That's Pulsafeeder. And those pumps actually have a higher repeatability rate, about a 1% plus or minus accuracy, versus this would be probably they publish it around 2. It's probably a 3 to 2%. Motor driven would be around 2% accurate.
Usually see
Plus or minus. Is there any pumps or anything specific you guys? I'll leave this open. We'll take this time wherever you guys want to go with it.
Questions, guys? Everybody know there's that many different types of pumps out there?
Pumped out?
You start getting overwhelmed after a while, it's like,
Yeah. There's a lot of opportunities out there for us to go after. And Burt offers a whole line, whether it's centrifugal, or whatever, and several different lines, and they have the experience and the technology to help us size these, figure out what's going on and everything, so. I mean, this is what we do to help solve problems and everything, so it's a good resource here.
The other aspect is we're not just pumps, we're also, we deal with pipe, but we deal with flow meters and instrumentation. So I consider us more process related. Like a traditional pump house, their solution is the pump. And I came from a pump house, which is fine, but 99% of the problems out there are process related problems. So what's nice is we can communicate on multiple levels. On if your customer's having an issue, we can determine if it's pump related or process related, and then help you guys and your client figure out what the overall solution is best for them. Because it might be valving changes, or piping changes, or putting in a flow meter or a level controller in the tank that's communicating. There might be some part of that beyond just the pump. And that's where I think we can help out beyond just the pump aspect.
We do have another training session come up January 8th. Right, Dan? Signet flow meters.
Yeah.
We're gonna try, I'll get with you guys, we're gonna try to do that the afternoon, because our field marketing summit's the next day. So we're gonna try to do that in the afternoon. I think we got set up, we'll confirm that. It's January 8th though, and our field marketing summit's the 9th. So that is Signet flow meters. We're gonna be working on that, mag meters, paddle wheel meters. They got a pretty good line on there, so
Yeah.
we do some
One
training
of my
on that.
customers buys some of them from you.
Yeah, yeah. And you were out there with Kevin, with you
Yeah.
at,
Dr. Pepper.
Dr. Pepper,
Yeah.
you know, and how'd that work out? Did they
They're gonna
switch
buy the
over to the mag
mag,
meter?
Customers, so I think
they're gonna buy the mag type, but that mag type in,
One
they just
thing,
haven't
I
done it
can't tell
yet,
them
just because it's
anything.
me, I think
They buy them
that's what
from
they're gonna do.
Like
Yeah.
every couple months,
Yeah.
they buy one.
I think they'll get better
I call in, you know
better
what?
flow,
Accuracy.
accuracy too, yeah.
Yeah.
Because they weren't getting the right readings at the
No complaint, as
Correct.
long as they call
Yeah.
it.
shed or shack, whatever
Yes.
you call
What
it.
it is.
Yeah. Under the water flow, but there's a lot of applications like that.
Yeah. Any other questions, guys?
Good stuff.
Hope this was helpful.
Feel free to get me involved, and I'll get Lanny involved or whatever. But and we have other guys besides Lanny. I mean, but it seems like you guys are all comfortable with Lanny, whether Lanny he is what he is. But you know,
He knows his
No,
stuff.
yeah, he knows his stuff. So
we're still planning on sometime, we're not sure date, first quarter or so, is doing a pump seminar for our customers. You guys all, obviously we can try to, give me your thoughts on that, what content we wanna have in, more on, less on of this, whatever we wanna do. We'll work that all out, but sometime in the first quarter, we wanna do it for our customers, and do an all-day one, so.
is it going to be something diversified like this, or do you
I
want
think,
it
so.
to
what do
be
you guys think? I mean, what do you?
think that would
more,
make the
more
most sense.
pump
Yeah.
specific, or like diaphragm pumps, or
We could probably, we'll talk that out, try to sort that out, give you maybe a little bit more on diaphragm pumps and maybe more on this, less on this, or, but definitely the basics I think are good for our customers too, to go over some of that, so we can sort some of that out, but
more
That's
for
our-
maintenance guys.
yes,
Yeah.
yes, yeah. So that's our goal, probably,
Knock down some pumps with.
exactly, we'll rent, some facility somewhere we can, get 50, 60 people in
Yeah.
or something like that.
Go over like water hammering and all that, and how to fix
Yeah.
that, and all that, all
Yeah.
that different kind of stuff. That pulsation dampeners, when to use those, and just
Yeah.
stuff that.
So
and-
we can sort that all out, what we all want and everything, cater to that, so, you
Yeah.
guys all think I have a good idea then to?
Yeah.
Yeah.
Yeah. Okay.
yeah, up to that
We
point.
might end up, if it goes, we'll probably do one down here around the York area. Works out well, maybe we'll do one up north in the Williamsport area and so you don't have to drive as far then, so,
Yeah, yeah, and till then though, I mean, you guys out in the field, ask your contacts, your maintenance guys,
Yeah.
what some of the issues are, what would they like, if you did have training, what would they like the training on, because everybody will be a little different. Maybe you can accumulate what they're really interested in. I'm sure we, as well, but.
I get plenty of hands-on stuff. I
Yeah.
got demonstrations, I mean,
I think that works well, if we do that, the hands-on is really,
Wine those
really
guys
Yeah.
will bring the,
nice, yeah.
bring the Twizzlers where everybody that works in the sewer plant was reaching out.
Yeah.
Do you remember that? Were you here at the last pump seminar?
no.
Oh,
Sounds like it
wine
went
those
well.
guys brought Twizzlers in, and you see these other maintenance guys coming in and they're all grabbing out this bag of Twizzlers, one's got on it, like, and the next guy just grabbed it right out.
The maintenance guys, they don't care.
Yeah.
Comes up to me, I'm like, no, thank you.
I'm a diabetic, I can have that stuff.
Yeah.
Oh.
Well, thanks guys, I appreciate
Okay.
it.
Everybody has Dan's card, you know how to get a hold of him. He's gonna be looking forward to your call, so, get out there and
Sell some
work on
pumps.
work on some applications.
Pump it up.
Pump it up.
Pump it up.
I live in Massachusetts. What's that?
You go to Williamsport very often?
Once every maybe
Thank you.
5
Yeah.
years.
See, if you hurry up and box all this up, I can carry some down
My
for you.
card.
Yeah.
I have
Line
a
card.
guy
It was a- I
who
don't-
has
I
a
don't think it was
problem.
on my desk.
It's not a big pump. It's like a submersible, you know, he doesn't use the sewer line. He
It's
has
just on my
now,
desk. There was no phone call or
the
anything.
last 3 have failed.
I just found line card.
Can't figure out why. Simply cannot figure out why.
You carry the big.
They were little Meyer pumps, okay? And they were so, where we got them.
Look at this one,
The new
Suzanne.
one, well, after now they're going, now there's something else
Suzanne.
going on. They've talked to his electrician.
Did you turn that
They
thing off?
said there's a dry, they went through the whole thing.